Welcome. Today is the last section of Chapter 6. We have learned a lot about different types of quadrilaterals throughout this chapter. So today what we're going to do is we're going to organize all of that information. So the first thing we're going to do is we're going to make this or fill out this lovely chart to organize all these definitions we had about the different types of quadrilaterals. So the first thing, if you can see right here, this is going to end up being a flow chart. So we can see how the different types of quadrilaterals connect or relate to each other. So let's see. First of all, we're going to start with the main group, just a quadrilateral. Remember that a quadrilateral, that is a four-sided polygon. Now let's look at some different types of quadrilaterals. We gave you a little shape bank. So let's see, that one up there that kind of looks like a diamond, that is one example. Let's see, oh, that's not a triangle, not a quadrilateral. Right here, that's an example of one. I'm going to sketch it in my example bin. Here's also a quadrilateral. Not a quadrilateral, not a quadrilateral. Here's a quadrilateral. Here's a quadrilateral. Here's a quadrilateral. That one's kind of funny shaped. There, that's my best attempt at drawing it. And lastly, we also have that quadrilateral. Now let's see. If we scroll down, let's see, quadrilateral, that's our overall group, our kind of our heading group. We also have, but we learned about a lot of other different types of quadrilaterals. For example, parallelograms. So I'm going to write that right here. That's another group of quadrilaterals. Parallelograms. Now our definition for a parallelogram is a quadrilateral with both pairs of opposite sides congruent and parallel. Let's see now, if we kind of scroll up, if we look at that shape bank, do we have any parallelograms in here? Well, let's see. And this is kind of one of those things that we kind of have to look at and kind of estimate what shapes look like both pairs of opposite sides are parallel and congruent. So right here, right there, that's a parallelogram. We can tell that it looks like these sides are congruent, that side is congruent to that side, and they both look like they're parallel as well. So we can go down and we can sketch that one. Let's see, is there any others? Let's see. Right here, that looks like a parallelogram. Also, this one right here is a parallelogram. If we look at it, oh, those sides look congruent. Those two sides look congruent. That looks parallel to that, and that looks parallel to that. Same with this one right here. Let's see, I'm going to scroll down. I'm going to sketch all four of those parallelograms. Let's see, we had this one. That was not a very good sketch. We had this one, and we had this one. Let's see. I'm going to tidy that one up. The next group we're going to talk about is the rhombus. And we're going to talk about the rhombus right here because that is actually a type of quadrilateral. So let's see. Our rhombus, I'm going to scroll in here. It's a quadrilateral that has four congruent sides. And all those sides also happen to be parallel. If we go, let's see, our two examples, we can go all the way back up to our shape bank of quadrilaterals. Let's see. There are two, let's see, rhombuses where all four sides are congruent. Would be this one right here and this one right here. So I'm going to go down, I'm going to sketch those. We have this one. We have this one. Oops. Another kind of parallelogram that we talked about are rectangles. Now again, rectangles are going to have opposite sides parallel. There are a type of parallelogram. Let's see. Our definition of a rectangle is a quadrilateral that has four congruent right angles. Let's see if we go back to our shape bank up here. That would be, let's see, this one has four congruent right angles, and this one also has four congruent right angles. So I'm going to go down and I'm going to sketch those. Now let's see if we look underneath this. We have another type of shape that is both a rhombus and a rectangle. That would be our square. And that is defined by four congruent sides and four right angles. And our picture would just be this right here of a square. Now, what I really like about this flowchart is you can really see how everything connects. So a square, rectangle, rhombus, parallelogram, they're all types of quadrilaterals. Within the section of quadrilaterals, we have parallelograms. And within parallelograms, rhombuses, rectangles, and squares, they're all types of parallelograms. A square is a type of rhombus. It is also a type of rectangle. This just helps us organize our ideas and our different quadrilaterals. Let's go to the other side. The other main type of quadrilateral we talked about was a trapezoid. And our definition of a trapezoid is it has one set of parallel sides that are opposite from each other. Set of parallel sides. I'm going to write this one set of parallel opposite sides. And if we go up to our shape bank, let's see our trapezoids. Let's see, this would be a trapezoid right here. We have those parallel opposite sides, and ooh, it looks like this is a trapezoid right here with these parallel opposite sides. I'm going to scroll down. I'm going to sketch those out. Let's see our other one. What did it look like? Whoops. Okay. Like that. And finally, we have one more. We have the isosceles trapezoid. And the definition of that is a trapezoid where the non-parallel sides are congruent. Now if we just kind of look up what examples do we have, let's see, well, of our two trapezoids, it doesn't look like these two sides are congruent on this trapezoid. These two sides don't quite look congruent. But these sides right here look congruent. That's our example of an isosceles trapezoid. So we're going to sketch that one in right here. Okay, and there you have it. Now, using all the information we've learned this whole entire chapter, we're going to reason some things about our different special quadrilaterals. Decide what kind of quadrilaterals are the given pictures. Okay, what type of quadrilateral is this? So let's see, we have quadrilateral A, B, C, D, and all that they told us is that, let's see, they drew in the diagonals AC and BD right here, and what they showed us is that where they intersect right here, let's see, and that's at point E, it looks like DE is congruent to EB and AE is congruent to EC. Well, it looks like the diagonals bisected each other. They cut each other in half. Now let's see, we have a theorem that talks about this. That's theorem 6.9, if you remember back there. Theorem 6.9 says that if the diagonals of a quadrilateral bisect each other, then that quadrilateral is a parallelogram. So this right here is a parallelogram, and that's because of theorem 6.9. Okay, let's look at another one. Are we given enough information in this diagram to conclude that ABCD is a square? So let's see, what we know is we know that all four sides are congruent. For a square, we need to have all four sides congruent and all angles right angles. But we don't know anything about the angles right here, right? They kind of look like they're right angles, but they're not actually telling us. So we would say that we do not have, we don't have enough information because we don't know about the angles. So let's see. Not enough, info. We do not know about the angles. Okay, are we given enough information in the diagram to conclude the EFGH is an isosceles trapezoid? Explain your reasoning. Well, let's see. The first thing that I notice is that, let's see, if this were a trapezoid, let's see, FG and EH would need to be parallel. So our question is, are they parallel? Now, you have to think back to what you learned about parallel lines previously. Let's see. It looks like angle F and angle E are supplementary. They add to 180, and that's because, let's see, if we look at it, 120 plus 60 equals 180. So angle F and angle E are supplementary, which means FG is parallel to EH. And if you kind of forgot the reasoning behind that, you could think about extending this line FG and extending FG and EH. And if you kind of filled in what you knew about the angles, let's see, by vertical angles, this also has to be 60. By vertical angles, this has to be 60. Then by, let's see, supplementary angles, this has to be 60 because 60 plus 120 equals 60. 60 plus 120 equals 60. This would have to be 120. By supplementary, these have to be equal to 180. So it would also have to be at 120. If you look at all of our angle measurements that we have now on this picture right here that I'm going to recircle in purple just so you can really see what we're focusing on, you notice that these are following all the properties of a parallel lines cut by a transversal. Right, we have alternate exterior angles that are congruent, alternate interior angles that are congruent, corresponding angles that are congruent. These are parallel lines. So let's see, we know that one set of parallel lines are congruent. That's good. Now it asks for an isosceles trapezoid. So right now we know it's a trapezoid. We need to know it's an isosceles trapezoid. Well, now if we think back to, let's see, (613), we would know that theorem 6.613 says that if base angles are congruent, it's an isosceles trapezoid. In this case, base angles are congruent. And theorem 6.13 actually says that we just need one pair of base angles to be congruent. If you can see, we have both pairs of base angles congruent, which is totally fine. 60 and 60 are congruent, 120 and 120 are congruent. So it's an isosceles trapezoid. Because FG is parallel to EH, and by theorem 613, their base angles are congruent, so that trapezoid is in fact an isosceles trapezoid. Is this a square? I want you to pause the video for a moment. Try this one on your own. Okay, let's go over this. Is this a square? Well, it looks like a square. They gave us, let's see, 4 congruent right angles. So we have 4 congruent right angles. Let's see, what do we know about the sides? Well, they don't tell us anything. So actually, this is not enough information. Because we don't know about the sides. Technically, though, they did give us enough information to say that this is, in fact, a rectangle, because it does have 4 congruent right angles. Okay, is this a rhombus? Well, let's see. The first thing I notice is that, let's see, we have 4 angles, 100, 180, 80. Opposite angles seem to be congruent. Angle X is congruent to angle Z. Angle W is congruent to angle Y. Well, let's see. We know that by theorem 6.7, this is a parallelogram. Theorem 6.7 says that if opposite angles of a quadrilateral are congruent, it's a parallelogram. Now remember, a rhombus is a type of parallelogram, but that doesn't necessarily mean that this is a rhombus. If we go back to our definition of a rhombus, that's 4 congruent sides. Well, we don't know anything about the sides. So we have to say that we don't have enough information. Because we don't know about the sides. We could say it's a parallelogram, though, but we can't say it's a rhombus. Okay, this is our last one, trying to figure out if this is a trapezoid. I'm going to give you a minute to try this on your own. Pause the video, and we'll talk about this in a moment. Okay, this one's very similar to the one we did earlier about an isosceles trapezoid. So the first thing we need to know is if there are 2 lines are congruent. If we have one set of lines that are congruent, parallel. If one set of lines is parallel. So if we just look at this right now, KL and JM seem to be our best bet for lines that could be parallel. So the big question is, are they parallel? If they're parallel, then 2 of their angles need to be supplementary. Well, if we look at angle L and angle M, well, angle L is 90 degrees, angle M is 90 degrees, 90 plus 90 is 180. So L and M are parallel because angle L and angle M are supplementary. So let's see, KL is parallel to JM. Now again, a parallelogram needs to have, a trapezoid needs to have one set of parallel lines. If we want to, we could also check and make sure that KJ and LM aren't parallel. They wouldn't be a trapezoid if they were parallel, because a trapezoid has to have one set of parallel lines. If it had two sets of parallel lines, it would be a parallelogram. We can check and make sure that LM and KJ aren't parallel. They don't look parallel, but just to be sure, let's see, we could look at angle J and angle M. Are they supplementary? Well, that would be 60 plus 90. Well, that's 150, so not supplementary. So KJ and LM are not parallel. So overall, we would say this is a trapezoid. Yes, because of this right here. KL is parallel to JM. Thank you for watching this video on section 6.6.